Hey guys, welcome to another PowerPoint. As you sort of discussed last lesson, we're going to have a really big focus on similar triangles in particular as we continue to look at similarity. Usual visual cues, just a really quick reminder, as well as the rule. Warm-ups, guys, you know the drill. If you can pause the video 5 minutes, come back once you're finished and we'll see how you went. Welcome back. So we have the sums here. Okay, so these ones here, we are obviously adding the numbers. We are starting with 1,000. We are taking away 333. Product, so we are multiplying, and 88 divided by 8 answers in the red. Expressing 6 on 18 as a decimal, that's a percentage, so let's go 6 divided by 18. And that should give us 0.66, and you might find that that reoccurs a little bit. Expanding, okay, so we are getting rid of our brackets. We are going to multiply these two, we're going to multiply 6 by everything inside of the brackets. So we end up with 6x plus 6 times 3, which is 18. Same deal here, okay, we are multiplying 2x by everything inside. 2x times x, which is of course 2x squared. 2x times 2, we multiply the numbers together to get 4, the x stays there. Factorizing, so we're looking for the highest common factor to bring out the front of our brackets. So we're undoing our expansion, if you like to think about it that way. So I tend to look for my factors and my highest common factors. So I can see 6 times 2, 6 times 2x, and then 6 times 7. So my common factor of 6 is going to go out the front, and everything else is going to stay inside the brackets. So I had a 2x plus 7 left over, which is inside the brackets. This term here, we are foiling out. So first, outer, inner, last, x times x, x squared. 5x plus 6x is 11x. So of course, we're getting into the habit of adding those two numbers together for the middle number and then timesing them together for our outer number. Last one here, what I like to do is I like to FOIL first, outer, inner, last, and then multiply by x right at the end. So you can kind of imagine you're doing something like that. Now it doesn't matter what order you do it in, as long as you do your steps correctly, but either way you won't end up with that actually. You will end up with, let's have a look, x squared, let's put some working in, plus 13x plus 42, and then we're going to expand the x one more time, so we get x cubed plus 13x squared plus 42x, and hopefully your answers look like that. So our new content for today, guys, we are learning to determine similar triangles. We're looking to identify the correct rule to determine similar triangles. So in the last lesson, you might recall that we started looking at similar triangles. Of course, similar triangles were when we had enlarged or shrinked. We had basically scaled an original triangle, whether to make it bigger or smaller. What we're going to do today is we're going to have a look at some rules that help us determine when two triangles are similar, and we use a bunch of rules for that. So this is because those rules can really come in handy when we can't physically measure or calculate some distances. So we might only have some particular values. We might not have all the angles or all the side lengths, but we still want to know when two triangles are similar. That's why we need these rules. Okay, so what we can do to help make our lives a little bit easier, we can use these for conditions or for properties that similar triangles follow. Okay, so instead of measuring all the angles and all the sides and seeing if our triangle is similar, we can get away with having only some of the information and applying these rules. So if you can copy these 4 rules down, we're going to go through them in a little bit more detail over the next few slides, but we have the 4 here. Now the letters simply match up to what we're comparing. So if you have a look, we have AAA, and all that means is that all the corresponding angles are equal inside. And so this stands for the angle, angle, angle rule. We have SSS, so all the corresponding sides are in the same ratio, okay? So that's key for our similarity. So if we think back to scale factor, okay? So we need to do that scale factor. We need to double check that all of our sides, produce that same scale factor. This is known as the side rule. In this one here, okay? So we have SAS, so we have two pairs of corresponding sides are in the same ratio, so they have the same scale factor applied. The internal angle, so if you think about if you have this side and then this side, well, the angle inside needs to match. It's very important. It can't just be any old angle. It does need to be that joining angle. And then the last one here, so the RHS side. So it's a little bit different. The R stands for a right angle, so they're both right angle triangles. And then H stands for hypotenuse, so the hypotenuse, and another side, so a random non-hypotenuse side, so it doesn't matter which one, it could be A or B, doesn't matter. But as long as it is definitely a right angle triangle, the hypotenuse sides are in the same ratio, so have that same scale factor applied, and then picking one of these sides as well. So let's have a look at some examples here. So two triangles are similar if the internal angles of one triangle are exactly the same. So they need to be equal to that of the second triangle. And so what we have here is an example. So we have the angle at point A is alpha, so it's a little Greek letter, but we can see that the angle at point R is also alpha. So they are definitely the same, they're definitely equal. We don't know what number alpha is, but we know that whatever it is the same. So alpha and alpha, so it could be 30, 40, whatever it happens to be, it is the same. Same up here, we have B or beta, okay, another Greek letter, and the point here at point B, the angle size is beta. At point S, the angle size is beta. And then last one down here is gamma. Okay, another Greek letter. The letters aren't important, guys. What matters is that the same symbol is used in all three, because that tells us that they are, in fact, the same. So this follows our AAA, our angle, angle, angle condition for similarity. And it means that the two triangles are similar. Okay, copy this example down, please. The next one, okay, so this one we need to have a little bit of a thought about it, okay? And this one is very reminiscent to the examples we were looking at in the previous PowerPoint. So the SSS condition for similarity. So if we think about what similarity means, it means that the shape is the same, the angles are the same, but the side lengths can be different. Now, even though they can be different, they do need to be related. They do need to have that same scale factor, that same ratio applied. Okay, so we do need to be very careful about how we go about calculating these. So what we would do is we would have to make sure that the same scale factor that was applied to each side. So whatever this side length AB was multiplied to get RS, well, that scale factor needs to be the same for the other corresponding side. So that might be B to C, so what was multiplied by B to C to get S to T, and then the same number should be multiplied by AC to get RT. So the one scale factor for all three sides is what we're looking for. And to calculate this, well, we go ahead and do those division tests that we were looking at. So let's have a look at SR, okay? So remember, new goes on top, old goes on the bottom. So side SR, that was the first one. Let's get rid of these. Matches up to AB. So we have 9 on 6. Well, to me, what does that look like? A common factor of 3. I have 3 on 2. Okay? So 3 on 2 is the scale factor, is the ratio, and I need to double check that the same one has been applied to all three sides. So let's compare. Let's go, we won't have a look, we ticked that one. Let's go to B and C. So BC matches to S and T. So old on top, sorry, old on the bottom, new on top, so ST. And then the old one was BC. So the new side is 10.5. There we go. And the old one is 7. And yep, good. That does simplify to 3 on 2. And then the third side, I can squeeze that in there. New on top, so RT all over AC, okay? So RT was 15, AC was 10, and that does simplify to 3, 2. Fantastic. So the ratio, the scale factor being applied was the same, 3 on 2. So it is a similar shape. You can see that. Okay, so the third rule that we're on the lookout for is the SAS, so the SAS condition, okay? Triangles are pretty sassy little critters. You need to be on the lookout for the SAS. Now this one is a little bit tricky because the order is important. We need to have, as we said, side and side matching, okay? That's fine. But the angle does need to be in between those two sides. So say, for example, we had side, and then this angle over here, well, that would not work. They would not be similar, okay? So what we're on the lookout for is that the two sides are proportional. So again, proportional simply means that they have that same ratio, they have that same scale factor. So we play that same game. Let's double check that the same scale factor has been applied to go from A, B to RS. Okay, so we have the new on the top, which is RS, the old on the bottom, which is AB, 9 on 6. Okay, simplifies to 3 on 2. Okay, good. So we have one side. The angles are definitely the same. So if you want, we could do alpha equals alpha. In a real problem, we might be given an actual, angle, certain number of degrees. Excuse me. And then we're going to check the other side. So we want to check RT is proportional. Okay, has the same scale factor. And what do you know? It certainly does. So we have SAS, and they are absolutely similar. Last one here, guys, okay, very, very similar to the previous one, except we are following the new rule, the fourth rule, which is RHS. So it needs to be a right angle triangle, good, definitely right angle triangle, and then we need the hypotenuse and one other side to be in proportion, which means the same scale has been applied. So the number that we enlarged by in the hypotenuse needs to be the same as the number we enlarge our other side by, okay? So as we said, we've already ticked off the right angles. Let's check the hypotenuse, and we do that by calculating that scale factor. So to calculate the scale factor like we did before, we are going to compare those hypotenuse, so the scale factor for the hypotenuse side first. So we have the new side, which is ST, divided by the old side, which is B to C, okay, S to T. So 12 divided by 6, 2. And you guys might have spotted that, okay? 6 times 2 gives us 12. So that's the hypotenuse. Let's compare the bottom side. And we have the new divided by the old. RT divided by AC is equal to 10 divided by 5, which is equal to 2. This tells us they have the same scale. They are in proportion. It also tells us that it is similar because we satisfy the RHS rule. Right angle, hypotenuse are in proportion, and one other side is also in proportion. So if you only had the hypotenuse was in proportion, or you only had the side, okay, it wouldn't work. You do need all three things there. Okay, so we have a we do here, guys. All we're doing is matching the tests over here on the right, included for your assistance. And we're going to see if we can match up those tests with these following pairs of similar triangles. Okay, so I'll show you what we're doing for the first one. So I can see that we have a square, square, circle coloured in, hollow circle, hollow circle. So we're just using symbols, okay? We don't need to know what the actual numbers are. All that we need to know is that the square, okay, the square is the same size as the square, so they match up, okay? And what we're going to do is we're going to come over here and we're going to see which tests match. And right off the bat, we can see, well, that is AAA. All the angles are equal. So that automatically satisfies that rule. And that's all that we are required to do for these questions. So have a go, pause it now, come back in a minute or two once you've matched up those rules for B, C, and D. See you soon. Okay, so what we're looking for now is if we jump to B, we're looking for the rule that tells us that these two triangles are similar. So notice that we don't have all the angles on this one, so it's not going to be angle, angle, angle. We don't have all three sides, so it's not going, let's update our list as I'm going. So it's not angle, angle, angle. It's not side, side, side. We have side, but the angle needs to be between those two. So it can't be SAS. Hopefully it's RHS, and let's double check. Well, it's definitely a right angle triangle. We have that there. Now we need to double check that these sides are in proportion. We can see that we would need to multiply 3 by 3 to get it to 9, and our 2 would need to be multiplied by 3 as well. So it is a consistent scale factor. We didn't do any calculations, but we can see that times by 3, they are in proportion. So our hypotenuse and side are in proportion, and we do have a right angle. So it is RHS. I'm going to play the same game here, guys. I'll just rub out, I'm going to go down my list. It's not angle, 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 because I don't have 3 angles that match. It's not side, 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 because I don't have 3 sides. But SAS looks good. I have side, side, and the angle is in the middle. SAS, side, angle, side. So that looks good. The angles are equal. Let's double check that they're in proportion. So I would multiply by 3. So 7 times 3 is 21. And 6 times 3 is 18. Good. So I have the same multiplied by 3 scale. That means that they are in proportion. And using the SAS rule, I can tell that these triangles are similar. Okay? Again, I didn't need all the angles. I didn't need all the sides. I can simply get away with that information, which is the power of these rules here. D, last one here. So let's see what we're doing. Can I match these up? So what would I need to do to convert or scale my 6 to a 2? I can see I would divide by 3 or times by 1 on 3 if I was that way inclined. Got to be a little bit careful. Okay, so it's been mirrored as well, but that's okay because all we're looking for is some consistent factor, some consistent scale. So I could times 15 by a third to get down to 5, and I could times 12 by a third to get it down to 4. So fantastic, I have a third, a third, a third. They're all in proportion. All 3 sides are in proportion. Okay, so what we have here, guys, is a couple of really quick questions. I'm just going to run through them, and they run kind of matching intersections. So for the next few pages, we're only going to be looking at the AAA rule, then we'll move on and work our way through the list. So for each slide, what you're going to do is if you can pause it, have a crack yourself, and then compare our answers. Let's have a look. So determine the following, whether they are similar. Okay, so have a quick look, have a think, pause it if you need. And look, yes, absolutely, they are similar. Okay, and what we could do if we were really keen is we could actually go ahead and work out that unknown angle for both. So we can see that these two are already the same, okay? and that's fine. So if we were really keen, what we can do is we all know that the three angles inside of a triangle add up to 180. So we might call that unknown one x. We could go, well, x plus 72 degrees plus 35 degrees. Work that out for x, but because these two are already the same, we know for a fact that this unknown, I shouldn't call this x because I don't know that they're the same yet, we would absolutely know that it has to be the same angle, and therefore all three are the same. Pause it if you need to. And these ones here. Now this problem is the exact same thing. Okay, we would go ahead and we could work out what that last third angle is. Again, because these two are already the same, okay, we would know that exactly the same thing is going to happen. If we go 180 is equal to 114 plus 17 plus some unknown, let's call it x. Well, we can substitute these, substitute this, and figure out whatever x is, but it doesn't matter, okay? All we need to do is determine if the following triangles are similar. We know that this angle is going to be the same because all triangles add up to 180. So if the two are the same, the third must be the same. And as long as they're all the same, our triangles are similar. Next question. So if you guys can have a crack at this one, pause it, see how you go. And determine, again, if the following triangles are similar. They are not. This is the first pair of triangles that are not similar. And the reasons why they are not similar is the angles are different. 109 is not 107 degrees. Okay, 27 degrees is not 26 degrees. So because our angles are different, our rule does not apply. Therefore, our triangles are not similar. Okay, so moving on to our second rule, side, side, side. So we're checking to see if our sides are in proportion or the same scale factor has been applied to all. Okay, so guys, again, if you'd like to pause this, have a go yourself, we are going to have a look at that SSS rule. So we need to ensure that the same scale factor has been applied to all three sides. Pause it, and I'll see how you go in a minute. So here we have those three sides compared. So we can see that side AB corresponds to side XY. Okay, so what we're doing is we're going to go 4 on 5 or AB on XY. If you went the other way around, it really doesn't matter. You would get XY on AB and you would get 5 on 4, which would be 1.25. It really doesn't matter which way you go, okay? If you did it the way that's in black there, all the scale factors are going to be 0.8. If you did it the other way, it's just going to be the inverse of that, okay? So really not an issue. You should have still gotten the same scale factor for all three values, okay? But the important thing is making sure that you get the correct corresponding sides, okay? So you match them up correctly so that you get A to C definitely matches with X to Z. That's the important thing, that you pair up your sides correctly, okay? So because the scale factor is the same for all three of our sides, we can say that these ratios are equal, therefore the triangles are similar, and what we could do is we can write that mathematically. So triangle ABC is similar to triangle XYZ. That is the mathematical way of writing this sentence here. Okay, nice and shorthand. If you wanted some additional working, you could say according to the SSS rule. Okay guys, you know the drill. If you can pause the video here, have a go yourself, and we'll see how you went. So what we're going to do is we are going to compare the ratios for all of these. There's no listing for the points, so we can just whack our own in. You don't need to think too carefully about it. Doesn't really matter what you call the points, but we do need to have those labels in so that we can discuss the points, right? So what I'm going to do is I'm going to make sure I match up those sides properly, and I'm going to say, well, DE matches to AB, so I'm going to compare those ratios. Again, doesn't matter which order you do it in. looks like 3 on 2 if I simplify that. Cool, let's compare our long side on the top right hand, which is E to F and B to C. See how that's a little bit more exact than top right hand side. Good, so far so good. And let's check, so the bottom side, which is D to F and A to C, and I get 10.5, whoa, divided by 7. Good, okay, good. So therefore, triangle ABC is similar. So we have that little tilde again. Triangle D, E, and F. And if you're that way inclined, putting the rule in there is good practice. The same exact scale factor has been applied. Okay, the same proportion. Very important. Okay, so last one for this particular rule. If you can pause this one and have a go yourself, see how you go. We'll return in a minute or two and we'll compare our answers. So again, I'm just going to really quickly whack in some letters to help me talk about the side lengths. And F can be down there, so labeling my points there. And what I'm going to do, I'm going to start with the short bottom side, which is B, C, actually I'm going to go the other way around, D, F on B, C. No reason why I couldn't have done it the other way around. I guess I've just decided that on the left is my bottom side. Okay, 3 on 2 again, nice. Let's see what E and F, well that to me looks like it compares to A and B. Need to be careful, this one's a little bit tricky, it's been reflected. So that is 9 and 6, simplifies down to 3, 2 again. And then the last one here, so E, D compares to A to C, which is 10 divided by 7. And I know for a fact that that does not equal 3 on 2. If we whack that in my calculator, 10 divided by 7 is equal to 1.42, blah, 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 blah. So, what that tells us, guys, is that the same scale factor has not been applied to all three. All three sides are not in the same proportion, so they are not similar. Okay? That's how we prove that rule wrong, is by this not being the same as these two. So these are fine, these are good. We would need this to be 3 on 2 or 1.5, which it is not. So it is the one that throws our rule off. Okay? SAS, so our third rule. And here we have this example, okay? So 2 pairs of corresponding sides are the same, so we're comparing our 2 side lengths. So 22 divided by 11 is equal to 10 on 5, which is equal to 2 once you evaluate that division. And the angle in the middle here is the same. We don't know what it is, we don't need to, we just know that it's the same side. Okay, so what we have here, guys, is another SAS rule, potentially. What I need you guys to do is to have a go yourself and determine whether these 2 triangles are similar. So if you can pause it now, return once you've got an answer, and we'll see how you go. Okay, let's have a look. So, first things first, we'll knock out the easy one, which is the angle. Now, not only is the angle the same, but it is the correct angle. Okay, it is the angle in between those 2 sides. So we're happy that our A is satisfied. Next, we need to double check that the proportion or the scale factor for our 2 sides is the same. So we need that A dash B dash is in proportion with A on B. So that's this term on the left. And it needs to be the same as the proportion or the scale factor used for our other side that is corresponding or matching, which is A dash C dash and AC. We work that into our calculator. We do find that we get a scale factor of 1.5 has been applied to both, which is fantastic because that means that they are in proportion and we can say that they are similar according to the SAS rule. We would write that like so. RHS rule. This one here, guys, nice and quick. We'll run through these ones. Should be a little bit easier to identify because we can knock out some information just by sight. We have the right angle, the right angle. We need to make sure that the right scale factor has been applied. So we can check the proportion. Okay, 15 divided by 5, 6 on 2. Another way, do we need to multiply the same number by the same number rather to get this here, which is absolutely correct, we do. Okay. This one here for you guys, have a crack, pause the video, come together in a minute. I'll compare our answers. See you soon. Good. Well, we have angle A and angle A dash. Not only are they equal, but they are both right angles. Okay. Good. We're on track for the RHS rule. We will check that the scale factor is equal for our hypotenuse and our side. So making sure you match those up correctly. So 24 is our side and it matches with 8, which is our other side. And then of course 12 and 36 for our hypotenuse. Absolutely have the same scale factor of 3. Therefore, they are the same according to our RH. Guys, plenty to practice. There is a bit going on in that PowerPoint, so have a good read of it, have a good listen, and definitely try those worksheets. I'll see you next time.